My name is Johnson. I'm an associate professor from the University of New South Wales in Sydney, Australia. So actually for this topic, it's prepared by my PhD students, Ziang Blake, and my colleague Khalegh, and also my industry partner, James Linke. So a little bit background about this work, because I worked with the third keynote speaker, Dr. Simon Alvarez, for 2.5 years in University of Alberta before I moved to Australia. That was about 12 years ago. So, and since then, I tried to take the recipe Dr. Alvarez could explain this morning, and it took me 10 years to find the industry partner. And then we try to grow from the little, like try to have some collaboration. And then 10 years later, we have grown from zero, from scratch, to about $3 million research grants with one single industry partner. So anyway, this is only a small, piece of the collaboration we have been working recently. So a little bit of background about our work. So pretty much we try to look at the construction project performance, especially for the progress monitoring, cost and time control. And then, as we all know, even Dr. Carl has explained a little bit about the productivity in the second keynote today, and that's also one of the areas we're focusing on about the cost overrun. So I'm not sure if that's the latest version, but according to some general studies, there's like an average of cost overrun about 28% for infrastructure construction projects. I think that's pretty much very common worldwide. And then for our study, we try to look at the reality capturing, mobile laser scanning of the infrastructure construction, and then we try to understand how it's going for the progress. Are we on the right track about the time, about the cost? And then some of the research challenges we have faced over the years. For example, when we're talking about the Scan-to-BIM, most of the studies so far, I'm sure you have seen quite a few presentations in this ISARC conference. People are focusing on existing asset or building environment. For example, we try to scan the road and then develop the BIM model or digital model of the road. But during the construction stage, that becomes very, very challenging because every day you're making progress. The site is so chaotic and so complicated. And there are a lot of issues, a lot of temporary structures, even the materials, presented on the site, but they have never been modeled in a BIM. So that's about the temporary versus permanent structures. And also, it's about the progress, about the complex conditions. And then at the same time, people are talking about machine learning or data-driven methods. But in this case, when we're talking about the construction progress monitoring, I think the biggest challenge would be the availability of the data. Not only about the raw data, but also about the training samples. Who is going to collect the data for you? And then who is going to process the data that can be used as a training sample? Again, those are some practical challenges in construction industry. So that's the reason we try to develop this project, which, in this case, we aim to develop a fully automatic system. We can extract the progress of the road construction from some of the basic Scan-to-BIM methods we have developed here. And the input data would be the airborne LiDAR data. That's airborne laser scanning. And then in this case, we try to extract the boundary and of the key road sections from very noisy and complex site conditions. So here's just a quick workflow about the process. So first of all, we try to take the airborne laser scanning point clouds, and then Blake, my PhD student, tried to develop some of those feature-based methods and also graphic-based methods. And then finally, we try to combine them together and then generate and produce the site boundary from from this process. And here, just a little bit insight about the methods. For example, the first stage, when we look at the actual area we're going to focus on the construction side. So in this case, Blake has already developed some methods to like eliminate the information we don't need. For example, in this case, it specifically look at the stockpile, like the stockpile of the raw material, which is not relevant to the road construction. And other methods about the patch generation, so try to define the boundary of the road, and then also how to determine the center of the road. So here's the case study we have conducted with the data from the new airport in Sydney. That's the Western Sydney International Airport. So they have conducted the airborne scan of the construction site for the whole airport on a monthly basis. So here we took the data in 2023. You can see the differences over 1 month. And then this is a result in different stages, define the boundary, remove the irrelevant information, and then eventually we can generate the patch from the road, from the boundary. And then limited by the time, I probably wouldn't go through too much detail here. But here again, that's about the patch connection and also the refined results for road extraction. Just give you a little bit statistics here. So in this case, as you can see on the right-hand side, that's about the comparison of the progress over 1 month for the main road section of the site. And then in this study, based on some statistical analysis, we have achieved over 94% of accuracy for road extraction. Again, that is quite different to the BIM model yet. All right, so just try to quickly conclude the findings of this study. So in this case, we try to extract the road network construction site from the airborne LiDAR data, which is complex and also contain a lot of noise. So we have achieved 94.5% of accuracy for road extraction. And then in the future work, definitely we also try to even improve the performance and also try to combine the point cloud analysis with other sources of the data. All right. And here are the key references for the presentation. And also I'd like to acknowledge the funding support from Australian Research Council, which is equivalent to NSF in the state, or I think NRC in Canada. So this is like a 5 years research projects for ARC Research Hub for Resilient and Intelligent Infrastructure Systems. And that's my context details. But if you have any questions, I'm more than happy even to discuss further with you. Thank you very much.